And welcome everybody to space. Let's talk space and the weather therein. Happening since yesterday is Sunspot 3069 got a name. That's this group right here. Sunspot 3068 grew a bit. Sunspot 3070 needs a name. This area up here is certainly a sunspot. And we saw a nearly M-class flare from a new active region that hasn't even risen yet. We'll get into the details and some incredible slow-motion imagery here at the Smash News Network, least busted name in news. Thanks, everybody, for tuning in to the biggest hair in space weather. So here's a solar intensity gram. Sunspot 3068 has grown a little bit. You can see the umbrae is still spreading apart. We'll have 3 named sunspot groups by the end of the day today, or we should. Actually, it looks like Sunspot 3069 has since evaporated. But this group up here needs a name for sure. There is a group here. Well, let's show the colorized magnetogram. That's the best view. This group right here, that is certainly a sunspot, and it's quite magnetically complex. That will be known as Sunspot 3070. Interesting news about volcanoes. We've seen a major earthquake of 5.4 magnitude under Fagradalsfjall on the Reykjanes Peninsula. So increased magmatic activity happening there. Nearly 3,000 earthquakes recently detected under Iceland. So let's see, starting July 30th, the quakes have become shallower. So perhaps another eruptive phase about to happen around Fagradalsfjall. Karimsky, volcanic ash not identified in satellite imagery. Don't assume it's not erupting. And pole vault the caldera. Don't try to pole vault the caldera. Shivaluch exploding, flight level 150. Over the Kamchatka Peninsula from Shivaluch, that we can definitely see in satellite imagery. Mount Ibu on the Indonesian Isle of Halmahera exploding, flight level 070. 14,000-foot ash plume over East Java, Indonesia from Semeru. And moving down to Colombia, Nevado del Ruiz still exploding, flight level 200 over Nevado del Ruiz, flight level 230 over Sangay in Ecuador. That's an uptick at Sangay, I believe. 23,000-foot ash plume. And Revenador, 16,000-foot ash plume as Revenador explodes. Last but not least, Sabancaya exploding, flight level 240 over Peru from Sabancaya. It's a 24,000-foot ash plume. Next, we'll look at global seismicity. That's the past 90 days, and we did recently see this break in the 7-magnitude earthquake drought. Let's see what else has been erupting. It is a seismic uptick here worldwide. Again, with the most interesting one being a 5.4 on southwestern Iceland. So quite a few quakes here, mainly around the Pacific Rim, as one would expect. Pakistan saw one of the largest quakes of the past 24 hours. It was a 5.5. Doesn't look like it did too much damage there. And also an aftershock happening there. Only about 10 minutes after the initial 5.5. Little cluster of quakes there in the Aleutian Islands as well. So here's that 5.4 magnitude quake that happened at 1748 yesterday afternoon, Universal Time. So a series of 5 magnitude quakes happening here all in succession. Iceland, the Philippines, Japan, and another one in the same location in Japan. Those only 2 minutes apart. The time between the Iceland quake and the Japan quake only about an hour. So 4 or 5 magnitude quakes happening there in just 1 hour's time. Totally different parts of the world. Papua New Guinea had a 5.2. The Aleutian Islands saw a 5.3. Papua New Guinea also had a 5.4. So definitely a bit of a seismic uptick. And don't assume the 7 magnitude earthquakes are done just because the drought has ended. Again, this is a very small number of 5 magnitude quakes. 7 magnitude quakes, I mean. You can see how many typically happen here. We could be in a little bit more of a highly active seismic phase on the planet. 2017 was a very low year of earthquakes, by the way. You can see 2018, very different. Although there was a long drought in 2018, this is the past 90 days. So check it out. Great imagery here from 304 angstroms wavelength from the SDO. And if you're wondering if that new active region is a sunspot, well, most likely it is. It was nearly an M-class flare there, a C9.3. Again, we'll show some close-up imagery of that. That's the last 24 hours. The radio flux has come up a little bit to 94 solar flux units. There is the one-year chart of the radio flux. It's this black line. And looking at the Space Weather Enthusiast dashboard, NOAA was expecting some geomagnetic unrest this morning from a coronal hole stream. We actually did see a brief period of geomagnetic unrest yesterday afternoon. This is the last 4 hours of Earth's magnetic moment from space. Scaled here is magnetohydrodynamic pressure. The units, nanopascals. So things back to being geomagnetically calm. And we saw what looked like a weak coronal hole wind stream. We'll get to the data on that in just a moment. First, we'll show Earth's magnetic moment from the ground. The units here are nanotesla magnetic flux density. And like our geospace magnetosphere movie, this ground magnetic perturbations map is the last 4 hours. And thanks everybody for tuning into our daily space weather content. We've been doing it for the past 5+ years. There's your planetary K index. It is at 2 at the moment. KP2 is the current condition. Again, a brief period of geomagnetic unrest late in the afternoon yesterday. Moving to the real-time solar wind, we see what looks like a fairly weak coronal hole wind stream here. Density made it only up to about 20 protons per cubic centimeter. And the typical signature of coronal hole wind streams is the density dropping off and the velocity coming up. Velocity made it to about 550 kilometers per second now, more like 470 kilometers per second. Current solar wind density about 5.6 protons per cubic centimeter. Also a minor signal here down in this bottom frame, the plasma temperature. Next, getting into magnetic data. Here is your GOES magnetometer, the GOES 16 and GOES 17. Pretty chill as far as magnetics. That plasma stream not super dense or super fast. So here's our top view ecliptic plane field plot showing us the polarity of the solar plasma. And indeed there is a North Pole current sheet headed this way. It's already made it to stereo A. That's this little plus sign here. North Pole oriented current sheet possibly arriving as early as tomorrow, maybe even later today. So here's our line of sight field plot as the solar polar field reversal process continues through cycle 25. Coronal hole line of sight plot. And we are able to see some North Pole oriented coronal holes here rotating into the eastern limb. Here's a view of that from the SDO. It's the 193 angstroms wavelength. That's the last 24 hours. You can also see this solar flare in this wavelength. It happened at about 2300. yesterday on July 31st. So welcome to August, welcome to Monday. Sunspot 3069 has evaporated. This sunspot up here needs a name. That's Sunspot 3070. And it looks like definitely another sunspot about to rise in the northeast. So here are some close-ups. First, 1700 angstroms. That's the last 24 hours. Sunspot 3068 has grown and the umbrae have spread apart a bit. And here's a close-up magnetogram from SDO. And here's a close-up of the continuum imagery. Mostly stable, but a little bit of growth. So here's this flare we're talking about. It occurred just right around 2300 hours yesterday. Peak flux was 9.3, a C 9.3, nearly an M-class flare there. Quite close to being M-class. And here's the last 24 hours in 94 angstroms, a wavelength specifically designed to view solar flares. It takes 10 images per minute instead of only 2 like most of the other wavelengths. And we'll show some close-ups of that. Did you know this video was originally streamed live to Twitch? Thanks to our Twitch followers. Thanks to our YouTube followers. The new ones, the old ones. And the ones who've been watching for a moderate period of time. Congratulations on realizing that the channel exists. Welcome to space. We endeavor to show facts on the channel. Today's featured product is do not pole vault the caldera. Don't come up with a permanent solution for a temporary problem. No matter how good your field team is, please don't pole vault the caldera. It could be unhealthful. The people downwind don't want to breathe you in. And the people here at the Smash News Network, least busted name in news, don't want to hear about you becoming part of the lithosphere. Don't join a lava lake. Sacrificing yourself to the volcano gods is not going to prevent droughts or prevent earthquakes the way sheep's bladders may be employed to prevent earthquakes. So don't pole vault the caldera. Our finest days lie ahead. And accountability always comes. People on Twitter agree. Follow us on Twitter, twitter.com/smashomash. If you want to support the channel via subscription services, become a member of the Smash team. At the silver or gold level, smashomash.com/smash team. Thanks to all of our supporters over there. We are still on Patreon and so on. You can find our links at the homepage at smashomash.com. And welcome to the Neo-Renaissance. The realm of science is a rabbit hole, and when you enter that rabbit hole, you ask questions about nature, you use hypotheses, further observation, labs, etc., to attempt to disprove your own hypotheses, and often we end up with answers to questions not asked. That's just the way it works. Visit our homepage, smashomash.com. Visit us on social media. And thanks to everybody who's interacted over the past several years. So here are some close-ups of this C 9.93 solar flare. 9.3 solar flare, I think. There's a great close-up of the northeastern limb and also Sunspot 3070. How about a slow-mo? And we've slowed this down to 1/3 speed here. The last was 30 images per second. This is only 10 images per second. There's that rather long duration C9 plus level solar flare. We'll bring it back one more time. As we're wont to do, since our channel shows the most in-depth space weather in the world and the most detailed imagery of the closest star. Thanks for stargazing with us here at the Smash News Network, least busted name in news. We didn't see that produce any proton spikes there, no relativistic particles made it to Earth, at least not any that made the graph move. And we encourage our viewers to look up. This is what you get if you were able to see through the cloud cover here over Lehigh Valley, the sun just rising. Also Venus, Mars, Jupiter, and Saturn, they're up there on the ecliptic. If you've got a clear sky in the morning, you should have some great views of planets. Here's our solar system forecast. Here's where things will be in a week. We'll have a gibbous waxing moon on 8/8/2022. Let's take a look at some coronagraphs. Here's yesterday's imagery. And indeed, there was a coronal mass ejection associated with that large C.93 solar flare. C9.3, not 0.93. And this is today's imagery so far. We'll look at some more images here from Stereo A and the Soho Lasco C3. We don't expect that to be a coronal mass ejection directed toward Earth. We've got some missing data here on Stereo A, so this is a few hours old here. And it looks like we see some CME action on the far side of the sun there. You can see it coming out of the north and east portion of the Lasco C3. Again, we don't expect that to be earthly directed. Let's get into some more imagery here. Here's the hydrogen alpha imagery from El Teide, Spain. Some filaments in the south, some filaments in the north. A lot less than we saw about a week ago. We had an incredible number. And I would say that's most definitely a sunspot rising there in the northeast. Let's go to the NASA GO 16 SUVI. You can see a great prominence here, a bunch of plasma being suspended up there, battling the sun's gravity and being held up by magnetic fields. That's ionized helium you're seeing. And let's take a look. That's about the last 2.5 hours. Let's take a look at the last 24 hours in 171 angstroms, the house favorite wavelength. Press that share button. Get your friends and foes to view our content. Give Smash staff a raise for all of her hard work. She's our IT department and our social media manager. Did you know? Next, the space weather enthusiasts, the satellites community dashboard here. Some minor charging hazards over Mexico and the Central Pacific at the moment. Low energy electrons building up on the surfaces of satellites. Not likely to cause any major communications breakdowns. And here's our GOES electron flux. It's been a little bit lower here over the past couple of days because of coronal hole high-speed streams. This is the NOAA forecast. And you can see pretty accurate forecasting there on the relativistic electron forecast model. There's the 1-year chart. We're in a moderate range. We'll show the F ionosphere layer. It's located at about 300 kilometers of altitude. This data provided by Australian Bureau of Meteorology. That's the vibrational frequency in megahertz. There's a lot of vibration happening at the bridge between Earth and space, so we show it to tie together space weather and Earth weather as we slowly get closer and closer to our meteorology segment. Let's bring up the latest image and show the anomalygram. Here's your anomalygram, anomaly in megahertz from a 30-day median. Quite a lot of low-frequency anomalies here and some rapid shifts once again like we saw yesterday around the Arabian Peninsula. Some shifts from high to low-frequency anomaly. And there's 1015 universal time ionogram, 1015 universal time anomalygram. Next, the total electron content forecast. And we've got some major anomalies down here around Antarctica. You see some very high electron contents there. Right at the beginning. Let that play through a second time for you there. Some anomalous electron contents there south of Africa near the Antarctican continent. Let's play that through one more time. And that is the coupled thermosphere, ionosphere, plasmasphere electrodynamics. All of the electrons between your GPS satellite and your GPS handset. We've got the solar intensitygram, and we've got the solar magnetogram. So again, this group up here needs a name. That's sunspot 3070. That is quite a magnetically complex sunspot group. Whoops. So there's the magnetic fields of that. That definitely needs a name. Sunspot 3070 is my vote. Let us know in the comments what you think. But there's the rock back. And one more set of imagery here. How about this composite for yesterday and today from SDO? That's ionized helium and ionized iron. So 211, 304, and 171 angstroms. And it's time. Time to look at the world's largest waves. Yes, some large waves. And we've got some comments here from General Disturbance, who won't do Twitter, as Twitter unfairly censors people. Huh. No, not censorship on social media. That's impossible. It's impossible. These big tech organizations are completely objective. Pardon my sarcasm. And we've got a lot of comments here. Just a moment. General Disturbance says, in 1859, a fisherman came back with extreme sunburn because of the Carrington event. All right. It's not really more likely that a CME would reach Earth when there's coronal holes in front of us because the corona normally sends mass back. No. All right, and let's get to the realm of meteorology. Thanks for leaving comments, General Disturbance. All right, so let's get to our meteorology segment here. We had some Google Earth imagery up, and it's not coming through, so let's just move on to our nullschool.net. All right, so we're showing the South Sandwich Islands because, well, they've got some of the world's best surf. Check it out. The world's largest waves at the moment are 32 footers just west of the South Sandwich Islands. So if you want to go surfing in a very, very cold place, the South Sandwich Islands are a good choice for you. Lots of big waves in the Southern Ocean at the moment. All right, so we're going to go to our normally scheduled meteorology content here. Here's the West Pacific. We're looking at the surface winds to start out. Here are the surface winds, some very strong onshore winds here at Western Australia. And here are the jet streams of the eastern world. We've got a strong jet stream convergence happening there on Western Australia as well. Upper level winds. The 250 hectopascal winds are the jet stream. Here are the jet streams of the Americas. We've got some More significant jet stream forming here over the U.S. and a new anticyclone over the southern Rockies. As an upper-level high-pressure system takes hold there, you can see this clockwise rotation happening here. Right here, that is your anticyclone. And here are the surface winds of the Americas. Windiest portion of the planet, still this spot right here. And it looks a little calmer than yesterday. Here are the surface winds of the central world, Europe, Africa, the Middle East. And here are your jet streams. Some weak jet stream here blowing backwards over the Indian Ocean and North Africa. Here's your weather.gov map. As flood warnings continue in eastern Kentucky, less than optimal. Some gale warnings around Alaska and Hawaii. Red flag warnings and excessive heat continues in the Pacific Northwest. Flooding also forecasted for Nevada, southeastern California, and portions of New Mexico. Next, moving to our total accumulated precipitation map. We're going to create an animated GIF here before your very eyes because the data was not available when we did show prep, so we'll bring it out now. You can see another couple of inches of rain here forecasted for eastern Kentucky, which is suboptimal. Heavy rains also forecasted for northern Michigan. It looks like 4 inches or so there. Anyway, that's your 72-hour GFS total accumulated precipitation forecast shown in inches. And we're going to continue on here. Let me just check the life of the stream first. This video was originally streamed. Oh my goodness graciousness. This video was originally streamed live to Twitch. Twitch.tv/Smashomash. Here is your lightning maps. This is your NASA Goes lightning mapper. Here is your real-time lightning map from lightningmaps.org. We've got terrestrial lightning over the U.S. Let's see where it is. It's in central Illinois. Some significant lightning happening there. And that's where your active cells are. Here's your windy.com pressure map. We've got low pressure north and south of Iceland. And a significant high pressure system here in the northern Pacific. No, I've pressed the wrong key. And let's head to radar.weather.gov to see the U.S. Doppler radar. There is all 50 states shown. This map just refusing to animate for us the past few days. At least it's showing you a still image, and you can see strong storms here over central Illinois, south of Lake Michigan. There we go. We've got it animated. Chicago mainly getting brushed by, so the Windy City going to be very windy there as those storms move mostly south of Chicago. Here's your shortwave radiation map showing clouds and fog at nighttime. As some weather moves out of the Lehigh Valley area. Some rain here moving off into the Atlantic. There's your water vapor map. And you can see this clockwise rotation here over the four corners approximately. A lot of convective forces still at play there. A lot of moisture over Utah and Arizona. Looks like some heavy rains. So here's your recap. U.S. Doppler radar. Shortwave radiation showing clouds and fog. And we'll close out with water vapor as we do on the channel. Thanks for tuning into the Smash News Network, least busted name in news. And may that solar wind be at your back.